Let's Godot, a series where I recreate video game mechanics in the Godot game engine. I did a series that there's only one, so I'm not sure how many of these I'll actually make, but you're watching this one right now, so I guess there's at least one. And just to be clear, this is not meant to be a tutorial or a devlog or anything like that. Instead, it's more of a show and tell of how I went about making something in Godot. Anyway, this video is all about recreating the board movement in Mario Party. So, for anybody unfamiliar, and I'm not sure how you wouldn't be if you're watching this, Mario Party boards are basically a bunch of interconnected paths. Along each of those paths are spaces. Blue spaces, red spaces, event spaces, you get the picture. Players can then move along those paths, pass spaces, land on spaces, and trigger various events. Those are the basics at least. So, to start with, I modeled a very simple space in Blender, as you can see here. Nothing too fancy, but in Godot I can create a scene called space, and easily override the material for the center section to create different visuals for the different spaces. The type for this scene I chose was actually a path follow 3D, which might seem a bit weird at first glance, but the reason is so I can have the engine automatically place those spaces along a path 3D, as well as spread them out evenly over a curve. So I created a new scene for that path 3D as well. To avoid confusion, however, I called that scene a segment, as in a segment of a path, since path felt too similar to path 3D for me. More on that later. The logic to evenly space them along a curve is pretty simple. Get spaces returns all of the spaces that are children of that segment. Then, we loop over each of them and set their progress ratio based on which position they are in, divided by the total. The result is perfectly spaced spaces. And just for fun, I also made this a tool script so I can visualize how it looks in the editor before they're actually loaded in-game. This makes it easier to make sure things look right overall, although right now that's not super important. At this point though, I needed to have a character actually follow the path, which going forward I'll be calling an actor interchangeably. Now I could just slap a capsule mesh in there and call it good, which I would have done if I were just making this for myself, but this is a fancy YouTube video and all, so the first thing I did was pick up this nice model from GD Quest, link in the doobly-doo. Its name is Godot, which is adorable, and I'd say it looks much nicer than a typical capsule mesh, don't you think? Now, there are a lot of ways I can go about having an actor follow a path. I thought about making them a path follow 3D, just like the spaces, and to be honest, I think that might have been the better way to go. But for now, it's just a normal Node 3D with some special logic that we'll talk about later. So, next up, I added some logic that keeps the actor planted to the ground at all times. As long as the raycast is colliding, the actor's position will snap to the collision point beneath the actor, and conveniently, if it hits a space, we can also update the actor's current space variable to that space. Now, this is probably not the best approach long term, since the space an actor is on should probably be set explicitly through code and not by doing a raycast. But sometimes if something works, it works. You can always refactor later. So at this point, let's recap. We have a concept of spaces, segments, and an actor. But right now, there's no way to actually navigate the board. To do that, we'll need a network of some sort to connect everything together. That's where good old A-Star 3D comes in. This would probably be overkill if it were just human players, which right now it is, but it does allow an easy way to navigate to specific spaces, which would be very useful for a more advanced AI to use. Say, for example, the AI wants to go to the star space and has to choose a complicated route to get there. It would be much easier to simply use the pathfinding capabilities of an A-Star network than to do everything from scratch. So I'll use a network. When the board gets initialized, we first loop through each segment and call it setup function. This is just a function that spreads out the spaces along that segment, as well as gives each of those spaces a unique ID. Then, for each of those IDs, we add a point to the A-Star network at that position. Now, there's a small caveat here, which is that if the spaces ever change position for some reason, we'll need to update the network as well. But that's easy enough to do later, and it would only really become necessary if we had some sort of logic where paths are shifting around or something. So, for those segments, we connect each space to the next, moving forward along the path, since you can only travel along a path in one direction. And then once we reach the last space, we look at the list of next segments, which is just a list of the next possible segments it can reach, and then we just connect the last space from the current segment to the first space for each of those connected segments. The result is what you see here, a network of segments connected to other segments. Here's a diagram of how the system would work for one of Mario Party's actual boards. As you can see, the yellow lines represent segments, and the green and red dots represent the first and last spaces in those segments, respectively. Now, whenever an actor reaches the last space in a segment, the code looks at all the next ones. If there's only one, there's nothing to do, so it proceeds forward. But if there are branching paths, it allows the player to choose which one to take, then move to the start of that one. From there, the player can move forward until their move counter reaches 0. So, the thing about this system is that it makes it really easy to physically put spaces down at a board and have them automatically be aligned along a path. But one downside is that you have to create all of these smaller segments when there are a lot of branches. In fact, as you can see by this example, there are actually several paths that only have one space in them. Overall, I think the trade-off is worth it, but I could see having a solution that does away with segments entirely too, and simply connects spaces to other spaces. What do you think? Anyway, for now, this works just fine. Next up, I needed a way to only move a certain number of spaces per turn, so I modeled a dice block in Blender. I then created a simple scene just for a die, and that scene gets instantiated whenever an actor needs to roll a number. In the script, I just provide a couple of exports for the minimum and maximum value, as well as a hit function that will return a random value after playing a quick animation. It also automatically deletes itself. So at this point, the main thing left to be added was just a visual for choosing a path. To accomplish this, I started by modeling a simple arrow in Blender. Then in Godot, I created a scene that gets instantiated around the player whenever they reach a branching point. Here's the code that creates those arrows when the player needs to choose a path. The IDs being looped over are just the next possible spaces the player can go to. To get the midpoint, it simply gets the difference between the space's position and the player's. Then, using that difference vector, it calculates the midpoint with some simple vector math. Then the final step is to rotate the arrow along the y-axis so it's pointing towards the next space. After that, I added a simple animation to show when an arrow is selected, then hooked up some logic to allow the player to choose a direction. And the result of that is what you see here. Next up, I wanted to tackle something more interesting. A system for adding events to spaces. Now, when it comes to spaces, there are really only two things that an actor can do. They can land on a space, and they can pass a space. In Mario Party, both of those events do different things. For blue event spaces, only landing on them does something. But for, say, the bank space, you have to pay 5 coins when you pass it, and when you land on it, you get all the coins in the bank. Now, I could create custom logic for each space and do things that way, but I thought it would be more fun to have the events themselves be the custom logic, and then you simply add those events to a space. This would also allow for more customizability, as well as the potential to add something like hexes from later entries in the Mario Party series. Those would simply be events that you add to a space during game time that get removed once they're triggered. For now though, I created a board event scene and some inherited version of it for awarding coins, removing coins, passing the bank, and landing on the bank. I then simply added those events to those spaces and made some logic to trigger them when they should be. After that, I just did some final polishing, added some sound effects when you hit the coins, when you pass spaces and land on spaces, and this is the final result. Overall, this was pretty fun. If I did it again, I would probably do things a bit differently, but sometimes it can be better to try something, see what works, what doesn't work, and then start again with a fresh perspective. Hope you enjoyed. Thanks for watching.